Welcome to Chapter 7. This video is on Section 7.1, Polar Coordinates. Here are our objectives. One thing that we will learn in this section is plotting points using polar coordinates and doing a lot of conversion between polar and rectangular coordinates. You will find that polar coordinates have the ordered pair r theta, whereas rectangular coordinates are the coordinates that we're used to, which involve x and y. So here we learn about the polar coordinate system, and we have a fixed point at the origin called the pole, which is denoted here. And the ray is called the polar axis. And the end point is P. The distance from the origin or the pole to point P is R. And then the angle is theta. A few things to note is that if r is greater than 0, so if r is a positive value, then the point is located r units from the pole in the direction of theta. On the other hand, if r is less than 0, if r is negative, then basically the point P is in the opposite direction. So instead it will be heading in this direction down here. And if r equals 0, then it's located at the pole. A few more things to point out. Theta is a directed angle from the polar axis. So if theta is greater than 0, so if theta is positive, it goes in a counterclockwise direction from the polar axis, which is normal. And if theta is negative, then it goes in the clockwise direction. So here is basically what you will see. You'll see a polar coordinate system that looks like this. And really, we're just plotting these points. So in part A, r is 3 and theta is pi over 4. So we will find angle pi over 4, which is here, and from the origin, we will go out 3 units. So we'll be 1, 2, 3 right here. So this is point A. Now in point B, I want you to notice that we have a negative value for r. So what we'll do is we'll find pi over 6, which is our value for theta. And if I were to go 4 units from the origin, that would put me here. But because r is negative, what I'm going to do is go in the opposite direction. So pi over 6 in the opposite direction is on this axis here. So from the origin, I'm going to go 4 units in this direction. So this is B. Okay, now let's look at C. In C, now theta is negative. So remember, if this is my polar axis, negative angles travel in this direction. So negative 4 pi over 3 is going to be, it's actually going to be, it will be here. So we need to go 2.5 units from here. So this is where C would be. Let's try some more. So now we have 5 and 9 pi over 4. So 9 pi over 4 is just a little bit more than 2 pi. So it's 2 pi plus pi over 4. So that will actually put us at pi over 4 and 5 units out. So 1, 2, 3, 4, 5 here. 7 pi over 6 is here, 6 units is here, so this is E. And then we have negative 5 and 5 pi over 6. So to do this, the first thing we'll do is look for 5 pi over 6, which is here. But I don't want to graph in this direction because this would be a positive 5, 5 pi over 6. So we're actually going to go in the negative R direction, 5 units. So this is F. So the ordered pairs R theta and R theta plus 2 pi n represent the same point in polar coordinates, and I'll explain to you why. So we've already kind of dealt with this, but if this is the point P, so this is P or R theta, and this is theta, right? Then if I make a full revolution around, so if I add multiples of 2 pi to this, I'll get to the same point. So this is also R theta plus 2 pi, theta plus 4 pi, 6 pi, so on and so forth. So the next thing we're going to be asked to do is we are going to be asked to find 2 other polar coordinate representations, and we still want R to be 0. So with that being said, what we're going to do is we are going to keep R as 3, but then what we're going to do to the angle is we are going to add and subtract 2 pi. Because if we add pi, that's one full revolution in the positive direction. If we subtract pi, it's one full revolution in the negative direction. So if I have 7 pi over 6 and I add 2 pi, if I have a denominator of 6, 2 pi can be written as 12 pi over 6, same thing as 2 pi. So when I add those, I get 19 pi over 6. So one of my representations will be 3, 19 pi over 6. On the other hand, if I take 7 pi over 6, sorry about all this here. If I take 7 pi over 6 and I subtract 2 pi, so I go in the opposite direction. If I subtract 12 pi over 6, that gives me a negative 5 pi over 6, which is still here. So this ordered pair would be 3, negative 5 pi over 6. So there are 2 other polar coordinate representations with R is greater than 0. Now I've talked about this slightly, but sometimes we can have a negative R. And what that means is I would take my existing point and then I would add an odd multiple of pi. Here's what this means. So it's just kind of written here. So let's say we have this point here. This is P, which is R theta. Okay. Well, if I add or subtract pi, if I add pi, I get here. Well, this is negative r comma theta. If I add pi again, it gets me to the original spot. So what I'm saying is I can write this ordered pair as negative r plus some odd multiple of pi. So let's look at our next example. So now what we want to do is the same thing we did in the previous example. We want two other polar coordinates, but now we want r to be negative. So it might be helpful to sketch what this looks like, okay? So if we're starting off with r theta being 2 comma pi over 3 is here, here is 2, okay? So what we want to do is we want r to be negative. Okay, so I'm going to represent this as a negative 2. Now technically that puts me over here because we reflect it. Okay, so what do I need to do to this point to get it back here? Well, I need to take pi over 3, what theta is, and add pi to it. So pi is the same thing as 3 pi over 3 in this case. So pi over 3 plus 3 pi over 3 gives me 4 pi over 3. This ordered pair is the same thing as this. Okay, let's try another one. So what we'll do now is we will subtract pi. So we start off with the negative value for r. We take pi over 3 and subtract pi. Remember, pi is the same thing as 3 pi over 3. So this becomes negative 2 comma negative 2 pi over 3. And here is why it is the same thing as what we are given. So if I find negative 2 pi over 3, negative 2 pi over 3 is here. Well, this ordered pair is 2 negative 2 pi over 3. If I put a negative in front of r, that puts me back over here. Okay. Here are some more that I'd like you to practice. So pause this and find two other polar coordinate representations with r being positive and r being negative. So here we go. So if r is positive, that means I'm going to let r remain 7. So all I need to do then is alter theta. And to do this, I'm going to add a full revolution and subtract a full revolution. So I'm going to take 3 pi over 2 plus 2 pi. That gives me 7 pi over 2. So one ordered pair would be 7 pi over 2. Then I'm also going to take my existing theta and subtract 2 pi. This will give me a negative pi over 2. So this ordered pair would be 7 comma negative pi over 2. On the other hand, for part B, if I want r to be negative, that means that I want r to be negative 7. So I'm going to take this and I'm going to add and subtract pi. If I add pi, or 2 pi over 2, I get 5 pi over 2. Oops. So my ordered pair would be -7, 5 pi over 2. Right? I can also take 3 pi over 2 and subtract 2 pi over 2 to get pi over 2. So -7 pi over 2. If you want to see this graphically, 3 pi over 2 is here. Okay, and just suppose this is 7 units from the origin. So this is our given point. Now over here, if I choose 5 pi over 2, so this is pi over 2 is here. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So 5 pi over 2 is here. The negative flips it down here. Okay. Now what we're going to do is we're going to convert ordered pairs between polar and rectangular. In order to do this, there's a little bit of information that you'll need to know about, which is given here. Now, these items basically come from things that we've already talked about. So if this is point P, this ordered pair here can be represented as either r theta or as x comma y, depending on if we're talking about polar or rectangular coordinates. If we're talking about rectangular coordinates, I can think of cosine of theta, if this is theta, equals x over r in this case. Well, that's where this comes from, just multiplying both sides by r. Okay, so if you're wondering where these things come from, it just comes from SOHCAHTOA. So these are things that you need to remember. X equals r cosine of theta, and y equals r sine of theta. Similarly, you'll want to remember this and this. Okay, so if I'm converting from polar to rectangular, you need to know these. On the other hand, if I'm converting from rectangular to polar, you'll want to know these. Let's give it a try. So I have this polar coordinate, and I want to convert it to rectangular. So this is r and theta. And this here is located, here's 5 pi over 3, 3 units puts me here. So it's important to notice that we are in quadrant 4. So whenever I get my rectangular coordinate, I want to also make sure that it is in quadrant 4. From the previous slide, we saw that x is equal to r cosine of theta, and y is equal to r sine of theta. We are going to use this information. So in order to find x, x is equal to r, which is 3, times cosine of theta, and theta in this case is 5 pi over 3. So you might want to think about the associated ordered pair with 5 pi over 3. It is 1/2 negative root 3 over 2. So in this case, we have 3 times 1/2, which is 3/2. So we found x to be 3/2. We're going to do the same type of thing with y. Y is equal to r sine of theta. In this case, r is 3, and theta is 5 pi over 3. I already know the associated ordered pair, so I'm going to multiply 3 by negative square root of 3 over 2, and this gives me a negative 3 root 3 over 2 for y. So this polar coordinate is equal to the rectangular coordinate 3/2, comma, negative 3 root 3 over 2. And this is in quadrant 4, so we are in business. All right, let's try another one. Why don't you pause this and see if you can come up with this answer. Here we have r and theta. X is equal to r cosine of theta, and y is equal to r sine of theta. Negative pi over 4, remember, we'll start here and go in the negative direction. So negative pi over 4 is actually equivalent to 7 pi over 4, and 5 units would put us right here. Okay, so again, we're in quadrant 4. So in order to find x, I'm going to take r times cosine of theta. 7 pi over 4 has the equivalent ordered pair here. So applying, oops, this should be a 4. Applying that here, we will have 5 times root 2 over 2, which gives me a 5 root 2 over 2. Now, finding y, I have y equals 5 sine of negative pi over 4, or 5 times negative root 2 over 2, giving me negative 5 root 2 over 2 for y. So this equivalent rectangular coordinate will be 5 root 2 over 2, comma, negative 5 root 2 over 2, which again is in quadrant 4. Pause the video and see if you can come up with the correct answers here. For part A, finding x, you should have 5 cosine of pi, which is equal to 5 times negative 1, or negative 5. Y is equal to 5 sine of pi, which is 0. So this ordered pair is negative 5, 0. And then in part B, you should find that x is negative 10 times cosine of negative 2 pi over 3. So negative 2 pi over 3, that ordered pair is negative 1/2 negative root 3 over 2. So this becomes negative 10 times negative 1/2, which is 5. Y is negative 10 times sine of negative 2 pi over 3, which is negative 10 times negative root 3 over 2, which multiplies to be 5 root 3. So this ordered pair is 5, comma, 5 root 3. Now we are working in the opposite direction. Now we are given rectangular coordinates and we want to convert it to polar coordinates. We are told some important information, that r is positive and that theta is in between 0 and 2 pi. So from a previous slide, I want you to recall that r squared is equivalent to x squared plus y squared. So I know what x and y are. They're given to me. So I can find r by using this formula here. So r squared in this case will be negative 3 root 2 squared plus 3 root 2 squared. This gives me 18 plus 18, which is 36. To find r, I take the square root of both sides, and I find that r is plus or minus 6. But because I was told that r has to be positive, I'm going to use r equals 6. Done. All right. Now, we were also told on a previous slide that tangent of theta is equal to y over x. Again, I know y over x, so I can find tangent of theta. Tangent of theta is equal to 3 root 2 over 2, 3 root 2 divided by negative 3 root 2. So tangent of theta is equal to -1. Okay, so let's analyze this a little bit. This ordered pair is in quadrant 2. If I were to plot this, this is in quadrant 2. In quadrant 2, theta, tangent of theta is equal to -1 when theta is 3 pi over 4. So I know r and I know theta. So this rectangular ordered pair is equivalent to this polar coordinate. Let's try another one. Okay, so this is rectangular, so I know that I'm given x and y. I want r to be positive and r to be negative, so I want two representations of polar coordinates here. Okay. So this ordered pair is in quadrant 3 because both of those values are negative. So r squared is equal to x squared plus y squared, which is equal to -2 squared plus -2 root 3 squared, which is 4 plus 12, or 16. So if r squared is 16, sorry about that, then r is plus or minus 4. Okay, and we're going to need to use both of these because we want two representations. So now we need to find theta. So tangent of theta, recall, is y over x. So in our case, we have -2 root 3 divided by -2. This reduces to the square root of 3. Now, I told you to remember that one of the things you were asked to memorize at the beginning of this class was that tangent of theta equals root 3 at pi over 3. Okay, so this is in quadrant 1, so I know that my ordered pair needs to be here. So there are a couple ways I can write this. I can write this as 4, 4 pi over 3, because if that's the case, theta is 4 pi over 3 here. And this would be a distance of 4. Or if I go in the opposite direction over here, that would be a -4, but my ordered pair would be pi over 3. So remember, for this, I would start at pi over 3, and then the negative would really put me here, right where I want to be. So these are the two solutions. Okay, here's another one. And this gets a little confusing, so hang tight. Okay, so we know x and y. So r squared is equal to 2 squared plus -4 squared, which gives us 4 plus 16, which is 20. Then you'll take the square root of both sides and reduce that radical. So r is plus or minus 2 root 5. Okay, we want r to be positive, so that's helpful. We know that we're going to use a positive 2 root 5. Now we need to find theta. So tangent of theta is y over x, so -4 over 2, which is -2. Now this is not on our unit circle, so in order to find theta, we will take tan inverse of both sides. So theta is equal to tan inverse of -2. All right, now let's talk about this for a moment. We know that tan inverse is going to be in one of these two quadrants. If tan inverse is negative, we will end up in quadrant 4, which is right where we want to be. So in order to end up where we want to be, we need to be very careful here, and we want to ensure that we get a negative solution. So we will add 2 pi. So our answer will be 2 root 5, comma, 2 pi plus tan inverse of negative 2. Now again, what's going to happen is this gives us a negative output. Okay, so if you plug this into your calculator, it's negative, which means it is not in this interval. Okay, so that is why we are adding 2 pi, because 2 pi is going to get us back to the exact same place, and it's going to ensure our result is in that interval. Okay, here, this ordered pair is x and y. This is in quadrant 4, and we want 2 representations, a positive r and a negative r. So, just like before, r squared is 2 squared plus negative 3 squared, which is 4 plus 9, or 13. So r is plus or minus root 13. We will use both of those. Additionally, tangent of theta is y over x, in our case negative 3 divided by 2. So theta is tan inverse of negative 3 over 2. Because we are not given any restrictions on theta, we can use this as is, and we do not need to add the 2 pi like we did in the previous example. Again, because there are no restrictions stated for theta. So what we can do is the following. R is positive root 13, so tangent inverse is negative 3/2. Now, if I use a negative root 13, I need to add pi to this. So it will be pi plus tan inverse of negative 3/2. Remember, we start with the angle and then go in the negative direction. Okay. Okay, now we're going to convert between equations in polar and rectangular coordinates. So again, we are going to use these two things often, and we are going to substitute into the equations. So here it says write an equivalent equation using polar coordinates. I know these are rectangular coordinates because x and y are involved. Anytime x and y are involved, they are rectangular coordinates. So here we know that since x is equal to r cosine of theta, I can replace x with r cosine of theta. So instead of x equals 12, I'm going to write this as r cosine of theta equals 12. Now, whenever we write an equation in polar coordinates, we always want r by itself. So my next step is to get r by itself. In order to do that, I will divide both sides by cosine of theta. So r is equal to 12 divided by cosine of theta. The next thing we want to do is rewrite this in a nice way. Anytime I have cosine in the denominator, I can rewrite it as secant. So my final answer would be r equals 12 secant of theta. We're going to do the very same type of thing in the next problem, but instead of using r cosine of theta, we know that y is equal to r sine of theta. So instead of using y, we are going to replace it with r sine of theta. So r sine of theta is equal to -6. We want to get r by itself, so we will divide by sine of theta. And if sine is in the denominator, we can rewrite this as -6 cosecant of theta. If the equation has r's and thetas, we know it is in polar form. Let's try one a little more complicated. Okay, so in this example, we have an x and a y. So anywhere we see x, we will replace it with r cosine of theta. And anywhere we see y, we will replace it with r sine of theta. So this becomes the following: 2r cosine of theta minus 5r sine of theta is equal to 4. At this point here, what we want to do is we want to factor out a GCF, which in this case is r. So when we factor out r, we are left with 2 cosine of theta minus 5 sine of theta is equal to 4. From here, we want to isolate r. So in order to do that, I'm going to divide both sides by this. So I have r equals 4 divided by 2 cosine of theta minus 5 sine of theta. Once I get r by itself, I look on the other side to see if there's anything I can do to simplify things nicely. In this case, I can't, so this is the final answer. Okay, in example 11, we want to do the same thing. So I'm going to replace x with r cosine of theta and square it. And then I'm going to replace y with r sine of theta and square that. Okay, so when I do this, since we have multiplication, I'm going to square the r and square the trig terms. So when I do that, I'm going to skip a step here and I'm going to factor out the r squared right away. So I'm left with cosine squared of theta plus sine squared of theta. If I distribute this r squared back in, I'll end up with the previous step. Now, you should be able to recognize that this is a Pythagorean identity. So this is all equal to 1. So if this is all equal to 1, then I can conclude that r squared is equal to 121. I can proceed because I want just r, so I'm going to take the square root of both sides, and I will find that r is equal to 11. This represents the radius of the circle, so it's going to be 11. All right, same type of thing. We have r cosine of theta is equal to 4 times r sine of theta, but all of that is squared. So this one's a little bit different. I'm going to go ahead and square each of these. So r cosine of theta is equal to, the 4 is not squared. The exponent is only attached to the y. There aren't any parentheses here, so y is the only thing squared. So I have 4r squared times sine squared. Now in this case, what I'm going to do is I'm going to divide both sides by r. The reason for that is the r cancels out here, leaving me with just cosine. And over here, it leaves me with just one r, which is ideal. Then after this, I need to get r by itself. So in order to get r by itself, I need to get rid of the 4 and the sine squared, and I'll do so by dividing both sides. So r is equal to, I'm going to rewrite this a little bit. I'm going to write it as 1/4 times cosine of theta over sine times 1 over sine. Because if I multiply across the top and across the bottom, it would be this. But I wanted to rewrite this so we can easily see that this reduces to cotangent and this reduces to cosecant. So this rectangular equation is congruent to this polar equation. Okay, here's another example. Okay, so this one is a little more complicated because there's just more involved. So this becomes r cosine of theta minus 5 quantity squared plus r squared sine squared. I just multiplied that right away. That is equal to 25. Now I need to FOIL this. So when I do, I get r squared, this is an r squared cosine squared minus 10r cosine plus 25 plus this is equal to 25. Well, I have a 25 here and a 25 here, so those will cancel one another out. Then I have r squared cosine squared and r squared sine squared. So what I can do is I can write that as r squared times cosine squared plus sine squared. Because if I were to distribute that r back through, I would have what I have in the yellow squares above. But hopefully from the previous slide, you'll notice that this is a Pythagorean identity and equal to 1. I don't want to neglect this piece here, so I still need to subtract 10 r cosine of theta. And this is now equal to 0 because the 25's canceled out. So cleaning this up a little bit becomes r squared minus 10r cosine of theta is equal to 0. All right, now I notice that there is an r in each term, so I'm going to factor out an r. And that leaves me with the following. Well, one very popular topic in algebra is the zero product property. So I can set this equal to 0 and this equal to 0. So either r is equal to 0 or r minus 10 cosine of theta is equal to 0. Solving this, I simply add 10 cosine of theta to both sides and I get r is equal to 10 cosine of theta. Now, this is the answer because this one, it would be redundant to write that as an answer also because it's really included in this answer because r equals 0 is simply the pole which occurs when theta is n pi. So really we only need to include this solution. Okay, so now we are going to go in the opposite direction. Now we want to convert from polar to rectangular. So there are a couple of hints here. You can do number 1, or you can do number 2, or you can try number 3. So I'll show you an example of each of these. So you can pause this and look at it if you'd like. Okay, so here are 2 examples. And what we want to do is rewrite this with rectangular form and then see what type of curve it is. So in this case, what I'm going to do is I'm going to square both sides. The reason is because if I square both sides, I know that r squared is equivalent to x squared plus y squared is equal to 15 squared is 225. I'm done. That's it. This is in rectangular form. Hopefully you can recognize that this is a graph of a circle. Okay, now what I want to do here on this one is I want to take tangent of both sides. So if I take tangent of both sides, I know from previous work that tangent of theta can be represented as y over x. So y over x is equal to tangent of 2 pi over 3. Turns out I know what tangent of 2 pi over 3 is because from week 1, when your teacher told you to study the unit circle, you did. So you know that in this case we have a negative square root of 3. We want to get y by itself, so I'm going to multiply both sides by x. So y is equal to negative square root of 3 times x. This is a graph of a line. Okay, in this case here, when I have something written as secant or cosecant or cotangent, sometimes it's helpful to rewrite this using putting it in terms of sine or cosine. So what I'm going to do is I'm going to rewrite this as negative 8 over cosine of theta. Same thing, okay, just written a different way. Now I'm going to multiply both sides by cosine of theta. So I have r cosine of theta is equal to negative 8. And hopefully this is recognizable and you know that this is equal to x, so x is equal to negative 8. Done. This is a graph of a vertical line. Here is the last example. In this case, what I'm going to do is I'm going to multiply both sides by r, which was recommended in one of those steps. So if I multiply both sides by r, this becomes r squared is equal to 10r sine of theta. We're smart, so we know that r sine of theta is equivalent to y. Now here, this is a little misleading because we don't want r and y. I need to replace this with something. Hopefully you remember that r squared is equal to x squared plus y squared. So we have this. Now this is okay, but it's pretty tricky to identify the type of curve that is represented by this equation. So I don't want to freak you out, but what's going to happen here is I'm going to have to complete the square in order to write this in a way to help us identify the type of curve. So I'm going to move this over by subtracting from both sides. So I have x squared plus y squared minus 10y is equal to 0. The x squared is going to stay as is, and this part here is what I'm going to complete the square on. So this will become y squared minus 10y plus a special little number is equal to 0 plus that same special number. Remember, this special number is found by taking b divided by 2 squared. So in our case, it's negative 10 divided by 2 squared, or negative 5 squared, which is 25. So our special little number is 25. Okay, so we end up with x squared plus, remember this can be factored into x minus 5 quantity squared is equal to 25. This is the equation we're looking for, and this is a graph of a circle. That concludes section 7.1.